We might not notice, but tremendous technology and mind-boggling science constantly surround us in the products we use every day. Behind their practical use lurk hidden histories, dramatic discoveries, and awesome experiments. They are wicked inventions. Coming up, pressure washers. How an alcohol incident led to a better way to clean. Steam engines. How can boiling water push a train down a track? Cheese. What is the connection between animal stomachs and the discovery of cheese? We reveal the history and fascinating production process for this fantastic food. We reveal the surprising science and amazing manufacture behind these wicked inventions. Pressure washers use high-pressure water spray to remove mud, dirt, or even dust from surfaces and objects, such as vehicles and buildings. But just how were they introduced?
Pressure washers, like a lot of inventions, actually came by accident. And it was a man called Frank Alfeld, and he was actually trying to create a portable whiskey distillery during the Prohibition time in America. In 1926, he discovered that actually the steam bursting out of his contraption was actually moving the grease on his floor, and he thought he was onto something.
This accidental creation turned out to be a wicked invention. When Alfeld searched for components for his steam machine, he collaborated with Frederick E. Schumann of the Homestead Valve Company. This model was known as the high-pressure Jenny.
A little bit later, in the 1930s, German inventor Alfred Karcher, he invented submersible heating elements, and this was part of the beginning of pressure washers. So he combined these elements to create what we now know as a pressure washer. And it was only in 1950 that he actually put all the elements together. The key element was the water, and it was the strength and the power of the water, the intensity of the water hitting a surface, that actually created the cleaning process.
This washer was called the DS350 Jet. This was his company's first of many products. The DS350 model relied on steam, whereas this wicked invention now has a high-pressured water flow, regulated temperature, and the ability of injecting detergent.
So since 1984, they've been available to the public, and now anyone can have a pressure washer to clean their car, they clean their patio or their driveway, and it's easy for everyone.
So, just how do companies such as Karcher make them today? Karcher, based in Germany, are world-leading producers of pressure washers for domestic and industrial use.
Karcher is the leading company of cleaning equipment in the world. Since 1950, we produce high-pressure cleaners and other cleaning equipment very successful.
The production of a pressure washer begins with the all-important electric motor, otherwise known as the engine. Here we can see the stator winding for this motor. 480 meters of copper wire are spun at very high speeds, a whole 150 turns per minute. This stator using the spun copper wire will essentially generate power for the pressure washer. The power is generated in these electromagnetic motors by passing alternating currents through opposing pairs of magnets to create a magnetic field in the motor's rotor, causing it to spin around fast and generate power. This particular motor will be able to generate 160 bars of pressure in the finished pressure washer, unleashing a whopping 600 litres of water an hour. Paper insulation is added to the motor before the finished unit is checked and transported to the next stage of production. The final step in the production of the engine is to mount the cable harness to it. Once this has been achieved, the basic engine is complete. Whilst the engine is being prepared, the plastic parts of the pressure washers are formed using injection moulding. At the injection moulding machine, raw plastic pellets are heated and pumped into purpose-built moulds that will form all of the external casings and covers for the pressure washer. These parts here will go on to form the hood and the chassis of the machine. Once moulded, the parts are stamped with all the relevant logos in another highly efficient automated process.
More than 50% of the value is automized with robots and automized machines. So we can produce very competitive in Germany in a high quality level.
The next production line is the motor line. The aluminium housing of the motor is prepared and fitted around the stator that was prepared earlier. From here, the machine is built up, step by step, in a number of assembly line processes. These include fitting the shaft to the rotor and installing the water inlet. This station is actually called the 3-in-1 station, as 3 processes all happen here. These are the screwing of the water housing unit, the oil housing unit, and also a leakage test. At this station, the motor housing and the cylinder heads are screwed together. If these parts are not in exactly the right position, the assembly process will automatically stop, thanks to optical sensors that are constantly operating. And after this, the pump set is complete. From here, the electrical system of the pressure washer, known as the E-box, can be assembled. This E-box controls all of the pressure washer's electronics, most notably including the connections of the main power cord and the on-off power cord switch. The machine then moves on to a fully automatic testing station to ensure that everything is operating as it should.
In high season, every 3 seconds we produce one machine. So we are able to produce up to 30,000 machines a day coming out of this factory.
Now that the pump set and all of the electrical components are complete and have passed testing, those injection moulded parts from before can come into play. The final assembled pump is placed into the plastic cover. The chassis and hood can then be assembled, as well as the handle, wheels and all other detachable items of the pressure washer. Once this has been done, the pressure washer undergoes more testing, and it is then complete. From simple spun copper wire to a super-powered cleaning machine, pressure washers surely are a wicked invention. Steam engines conjure up images of trains gently chugging across distant landscapes, whisking their occupants on a trip from a bygone age. But steam power is very much alive and an important power source today. In simple terms, a steam engine belongs to a family of machines called heat engines. All heat engines create mechanical work by converting heat or thermal and chemical energy to work, with a steam engine using steam as its working fluid. Though we often believe steam power to be a relatively recent invention, its roots can be traced back as far as ancient Greece. In the 1st century AD, Hero of Alexandria described a device called an aeolipile that seemed to use steam as a means of propelling a spinning ball.
A cauldron was heated and that water in there produced steam. Though then that steam was then injected into a sphere which had 2 small jets that popped at opposite angles to each other, and as the sphere was filled with steam, then it has to go out through the small jets, and it meant that the sphere rotated. It was an interesting toy, it was an interesting invention, and showing that steam could be used to push things along. But as the steam is essentially gas that's ejected, it's not that effective.
Over the centuries, mathematicians, engineers and great thinkers, such as Leonardo da Vinci, toyed with the concept of deploying steam for some useful purpose, with steam-powered organs, weapons and roasting spits demonstrating the concept's potential, but ultimately failing to catch on. It wasn't until engineers in the 17th and 18th centuries started to combine multiple inventions such as pressure, pistons, vacuums and cylinders that a commercial steam engine could be produced. Building on the work of fellow English engineer Thomas Savery, in 1712 Thomas Newcomen created a steam-powered pump for draining flooded mines, which demonstrated how steam power could be usefully and commercially harnessed.
A steam engine, in its simplest form, is heating water, which takes a lot of energy, When you heat the water, it converts to steam, that expands as a gas. It takes up a lot more space than the original water. Because it takes up a lot more space and is desiring to expand under pressure, if you put a piston at the end of the steam and it's well sealed, that steam will push against that piston. If you have that piston on the other end connected to something you want to do work with, as it pushes out, you get a conversion from whatever you were burning into water, into steam, and that produces work. Now that you have mechanical work and repeatable mechanical work, you could automate away a lot of processes that were very manual and laborious.
In Great Britain, the steam engine was to power the mighty manufacture of the Industrial Revolution, where new automated manufacturing processes and technology was to bring a period of technological dominance to the British Isles in the late 1700s and early 1800s. By this time, Scots engineer James Watt had improved the efficiency of the steam engine by making the piston create mechanical work as it moved in both directions.
The reason a steam engine works in both directions on a piston is that as you add pressure, that pushes this piston out. When you release that pressure, often there's a weight on the actual system that pushes it back in, but that escape of gas creates a suction and can pull the cylinder back. So as you add the pressure, you push it out, and as you release the pressure, you suck it back in, which is the careful design that James Watt designed to move the suction into a separate cylinder so that you can do work on both actions. Now, if you combine that with a wheel or a rotary system, you start to be able to produce, well, locomotion. You can move things forward. And the main designs thereafter started working around how do we get these cylinders to work at higher and higher pressures and more efficiently.
Arguably, without the steam engine, there would probably not have been the Industrial Revolution. Coal, which fueled manufacture and iron foundries, needed steam engines to allow for its mining. Trade and the economy could prosper as ships used steam to power through the world seas, and the steam-powered railways started to connect towns and countries. The steam train has become the most evocative symbol of steam power. But how do they move? A simple steam-powered train has a roaring coal fire, which takes the heat the fire produces and allows it to pass through the boiler inside thin metal tubes. The heat and smoke pass into the chimney and exit the train, but have heated the water inside the boiler and turned it into steam. The steam generated in the boiler flows down into a cylinder just ahead of the wheels, pushing a tight-fitting piston back and forth. The piston is connected to one or more of the locomotive's wheels through a crank and connecting rod, and as the piston pushes, the crank and connecting rod turn the train's wheels and power it along the rails. When the piston has reached the end of the cylinder, it can push no further, and the train's momentum carries the crank onwards, pushing the piston back into the cylinder the way it came. An outlet valve opens and the piston pushes the steam back through the cylinder and out up the locomotive's chimney. The characteristic chuff-chuff noise and smoke that a steam engine makes happen when the piston moves back and forth in the cylinder. They may be a beautiful piece of engineering, but unfortunately the steam engine is terribly inefficient, with 80 to 90% of all the energy produced from the coal they burn wasted. It was no surprise then that the increasingly economical petrol and diesel internal combustion engines of the 20th century became the dominant and more practical power source for driving global industrialization and mobility. Even though the steam engine has been relegated to a nostalgic role of romanticised machine of yesteryear, steam power is very much still in use today. A great deal of the electricity produced globally is created by turbines that are spun by steam generated by heating water with coal or nuclear fuels, and steam's historic use in transport has left other important legacies.
The steam engine has produced a lot of industrialization, has produced the rail networks in many countries that were needed in order to transport goods. If you transport goods, you can also transport people. You can then bring a better economy. You can also bring a freer flow of ideas. And as the steam engine grew its success, with the free flow of ideas, people in poor incomes could actually travel and see greater parts of their countries or other countries and bring a more egalitarian society.
From ancient Greek curiosity to nuclear-powered turbine, the steam engine is truly a wicked invention. Can we create a steam-powered boat from a juice carton? We're going to need an empty fruit juice carton, a tea light, some glue, a plastic bendy straw, duct tape, some blue tack, a craft knife, a drill, and an empty air freshener canister. To begin, cut open the empty fruit juice carton and fashion it into a ship's hull. Next, we drill a hole in the top of the empty canister the same size as the bendy straw. We glue the straw into place, making sure there is an airtight seal. Next, we drill another hole into the bottom of the carton for where the bendy tube can exit the boat. We carefully fill the canister with water and position the tea light under the canister. Using blue tack for ballast, we light the candle and place the boat in some water. Be patient, but soon you will see bubbles slowly seeping out of the straw. As the canister heats up, the bubbles will become continuous and your ship will start to move under its own power. Like a real steam boiler, when heat is applied to the canister, the water inside flashes into steam. The expanding steam pushes some of the water in the bendy straw, propelling the boat forward. The steam bubble then condenses, creating a vacuum which draws water back in through the straw. The cooled water that is brought back into the canister is then heated and flashed into steam, and the cycle repeats. Can we create a steam-powered boat from a juice carton? Yes, we can. Wicked challenge smashed. Cheese has been a popular food for centuries, but just how did a man's journey without food and drink make cheese what it is today? Cheese is a food derived from milk, and it is produced in a wide range of flavours and textures. The origins of cheese is shrouded in mystery. Many believe cheese was first created by an Arabian merchant who was in search of satisfying his hunger and thirst. His method was storing milk in the stomach of an animal.
Probably the most likely theory was storing milk in containers which had previously been stomachs of animals. Animal stomachs naturally contain rennet, and rennet is the agent which is needed to create the curds and the whey. So someone's obviously put milk in a stomach container and it's naturally produced cheese.
Curds and whey are produced when milk curdles. The curds are the solid form and the whey is the liquid form. However, it wasn't until 1851 that we saw the first cheese production factory.
You also find, going a little bit further forward, cheese factories popping up in places like Holland, the Low Countries, Belgium, Luxembourg.
The introduction of factories across the world saw perhaps the greatest steps towards consistent flavour in cheeses, which was when rennet became a mass-produced commodity.
It was a way, once again, for farmers to kind of preserve and extend the potential and the shelf life of milk. Now, milk shelf life isn't very long. Cheese shelf life, you've got years potentially. I mean, look at something like a Parmesan, which can be like 3 or 4 years old. So it always made sense to turn that milk into something else. And you start to see the rise of plastic processed cheeses, all the way from that kind of simple milk left in the stomach of an animal.
This method extends the shelf life of cheese even more, but is often criticised for its health effects, as flavours and chemical preservatives are added throughout. The production of cheese has seen many changes, but just how is it made? Henry Willig and his wife Riette took over the family dairy farm in 1974, where they had 30 cows. Not satisfied with only producing milk, they took a cheese-making course and brought their company into the cheese business. Fast forward over 40 years, and they now make cheese from goat and sheep milk too.
Well, Henry Willig Cheese, the company, was founded by my father, Henry Willig. 42 years later, we still make cheese in the company, and we do it on a much larger scale.
Tankers operated by Henry Willig visit around 50 Dutch milk farms to collect regular, organic and biodynamic cow milk, along with regular and organic goat and sheep milk. These lorries drive all over Holland, bringing back milks that make up over 95% of the cheese produced by Henry Willig.
So Henry Willig Cheese makes approximately 10,000 cheeses a day.
Within 24 hours of the milk arriving at the factory, it must quickly undergo 2 vital processes. The first process is only for cow's milk and is called standardisation, which makes sure the milk is of the right quality to be made into cheese. If it isn't quite up to scratch, cream and skim milk can be added to improve the quality. The second process is pasteurization, which involves quickly heating up the milk to about 75 degrees Celsius for 15 seconds and then immediately cooling the milk. This process kills and deactivates the unwanted enzymes and harmful bacteria that would make the milk go off quickly.
So the main challenges are, firstly, you need to have great milk. So we pay the dairy farms we work with extra if they deliver us first-class milk.
To turn the milk into solid curds, a starter culture and rennet is added. The culture is a bacteria excipient, which means it consists of natural lactic cultures. These work to convert the sugar in the form of lactose into lactic acid. It also encourages the renneting of the milk. This is when the proteins cluster and coagulates together. Fat molecules get trapped in the protein clusters, which cause the fat to solidify, slowly forming the cheese curd. After the curd is prepared, the lactose is washed out, leaving a mild cheese that will be deposited into moulds. But first, a variety of carefully chosen herbs are mixed in with the curds. These will season and add flavour to the finished cheeses to cater to different consumer tastes. The curds can then be inserted into moulds shaped like iconic cheese truckles. Pressure is applied to compact the curds as tightly as possible. This will result in a solid cheese later on. Now that these curds have taken the shape of a block of cheese, they can be treated. The blocks are deposited into brine, which is better known as salt water, where they are left to soak for around 8 hours. During this process, the salt is absorbed into the cheese, which firms the rind. This is the very outer layer of the cheese. After the 8 hours have passed, the cheeses are removed from the brine bath and placed on shelves in the storeroom to undergo a process called naturally ripening. If the cheesemakers are producing a batch of young cheese, then the ripening process is only allowed to go on for around 21 days. However, if a mature cheese is desired, the cheeses can be left for around 3 months. During this time, all the cheeses are regularly checked and turned. Each cheese is also coated in a special food-grade plastic, which is based on vinyl acetate copolymers. The plastic is applied as a liquid and allowed to dry. These steps help guarantee the best quality cheese with the best flavours. Once the cheese has been maturing for the correct length of time, the ripening is slowed down by coating each block in a layer of paraffin wax. This coats the cheese in a hard protective layer, which ensures air cannot reach the product inside, therefore reducing the chance of mould growth. The cheese is then kept in a cold room to allow the wax to harden and set. The final stage is to label and check the product. The cheese travels along a conveyor belt, where a machine places a round sticker on the top surface of each block. These stickers decorate the cheese whilst informing the customer of the ingredients, nutritional values and delicious flavours inside. After a single pass through a metal detector, the cheese blocks are boxed up and packaged, ready for delivery.
So when the cheese leaves the factory, part of it is being sold in our own stores. Also, we export a large part of our cheese production. We export to approximately 30 countries worldwide.
Whether in sandwiches or with fruit, these cheeses will be melting slowly in the mouths of people all around the world. Cheese, a deliciously wicked invention. So, there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing backgrounds. Pressure washers, steam engines, and cheese. All wicked inventions.